Hi everyone, one of you sent me this past IGCSE Extended Mathematics Paper 4 question on transformations, which I thought would be worth sharing with all of you. So here it is. We can see an XY grid here with three shapes A, B, and C, and the first thing we're asked to do here is to describe fully the single transformation that maps triangle A onto triangle B. And so we can see our triangle A right here and triangle B down here. And I should say, I do believe that the first couple of questions won't really cause any issue, so I'll be working through questions A and B relatively quickly. Okay, back to question A. Looking at our two triangles A and B, we can see that triangle B is a reflection of triangle A across the line y equals to -1. Indeed, that would be the horizontal line y equals to -1, and so I could write that answer here. So reflection across y equals to -1. There we go. Next, we're told to translate triangle A by the vector 6, -3. So each and every single point of triangle A gets moved 6 units to the right and 3 units downwards. So let's see, if I start with this point right here, if I move that across 6 units to the right, so that's 1, 2, 3, 4, 5, 6, and 3 units downwards, 1, 2, and 3 right here. And since I've already used blue, perhaps I'll change color. There we go, that's this point right here. And I do the same for this vertex here. So 1, 2, 3, 4, 5, 6, and 3 units downwards, 1, 2, 3. So that would be right here. And finally, I can move the point that's at the origin 6 units to the right and 3 units downwards. So that's this point right here. And now joining those 3 points together, we've now translated triangle A along the vector 6, -3. And I could go ahead and shade that triangle. There we go. Now I move on to the question of interest, which is, I believe, why one of you sent me this question. So that's question C. In question C, we're told triangle A can be mapped onto triangle C by a rotation followed by an enlargement. And the first thing we need to do here is use trigonometry to calculate the angle of rotation. Okay, well, looking at triangle A and triangle C, it's clear that to get from triangle A to triangle C, there's definitely been a rotation, and the center of rotation is the origin right here. And so the angle of rotation that we're trying to find is this angle right here. And what we notice is that this angle, which I'll go ahead and call alpha, is equal to 90 degrees minus this interior angle of triangle A, which I'll go ahead and call beta. So alpha is equal to 90 minus beta. And so provided we can find this interior angle of triangle A, we'll be able to find the angle of rotation alpha. So let's go ahead. If I zoom in for a second on that triangle A, we notice that although we don't know what this side length is equal to, nor do we know what this side length is equal to, we can see that the side length I'm hovering over right now is 2 times longer than this side length. Indeed, for this side length, to get from one end to another, we have to move 4 across and 2 upwards, and to get from one end to another of this side length, we have to move 1 across and 2 downwards. And so hopefully you can see, thanks to the grid that's provided here, that this side length is clearly 2 times longer than this one. And so with that in mind, let me show you how we can use right angle trigonometry to find this interior angle beta. Okay, so if I make a quick copy of that triangle right here, so it's a right angle triangle, there we go, looking something like this, and we have a right angle here, and the angle beta that we're trying to find would be this angle here. Now if I go ahead and call this side length x, so that would be x there, then because this side length is 2 times longer, we could label it 2x. And now relative to our angle beta here, x is opposite and 2x is adjacent. So using our knowledge of right angle triangles, we could go ahead and state that tan of the angle beta is equal to the opposite, so that's x, over the adjacent, which is 2x. And now hopefully you can appreciate that the x's will cancel each other out here, leaving us with tan of beta is equal to 1 over 2. And since tan of beta is equal to 1 over 2, or 1/2, we can go ahead and state that beta, the angle, is equal to arctan, or inverse tan, of 1/2. And so moving over to our calculator, we can now evaluate beta. Indeed, that would be equal to inverse tan of 1 over 2. And so I click on enter, and we're done. the angle beta we needed to find is equal to 26.6 degrees, where I've rounded my angle to 1 decimal place. And so now that we know what the angle beta is, we can go back to our angle of rotation alpha, which I'll copy down here. We had said that alpha is equal to 90 minus beta, which consequently is equal to 90 minus 26.6. And so using our calculator again, we can go ahead and state that alpha is equal to 90 minus 26.6, which we can see is equal to 63.4 degrees. And so I'll state my answer right here. There we go, 63.4 degrees. And although I don't think it's being asked for here, but I'll be a little bit more specific, and I'll even add that it's 63.4 degrees anti-clockwise. Anti-clockwise. And there we go. We're nearly done for the second part of this question C. We're told that the scale factor of the enlargement is square root of a, where a is an integer, and we need to find the value of a. And although we can't see how many points that's worth on the screen here, this part 2 is also a 3-point question. Okay, well, looking at our two triangles, A and C, to find the scale factor for enlargement, we need to compare two corresponding side lengths. And looking at triangle A here, we can see right away that its hypotenuse is equal to 5 centimeters, or 5 units of length. So let's try and compare that to the hypotenuse of triangle C, the enlarged triangle. And although we're not given the length of this long hypotenuse, we can see from the XY grid that this side length has a length of 10 units, and this side length has a length of 5 units. And so if I make a quick sketch of triangle C on the right-hand side here, it looks something like this, with my right angle here, and we have a side length of 10 centimeters here and a side length of 5 centimeters there. And so the hypotenuse, which I'll just call capital H, would be this side length here. Okay, well, because it's a right angle triangle, we can use Pythagoras' theorem, and we can go ahead and state that the square of the hypotenuse, so h squared, is equal to the sum of the squares of the other two sides. So that's 10 squared plus 5 squared, which becomes 100 plus 25. In other words, h squared is equal to 125. I carry on, since h squared is equal to 125, we can find the value of h by applying the square root. So h is equal to the square root of 125. Now, to make our life easier, we need to simplify this square root, which we do by looking for the largest square factor we have inside 125. And hopefully you'll agree that 125 is equal to 25 times 5. So we have h equals to the square root of 25 times 5. I can now split that into two separate square roots, so that's the square root of 25 times the square root of 5, and since the square root of 25 is equal to 5, we can state that capital H, that's the hypotenuse of triangle C, is equal to 5 root 5. And I'll go ahead and box that result. There we go. We're nearly there. All we have to do now to find the scale factor, and therefore find the value of A, is divide this length, so the length of the large hypotenuse, by the length of the smaller hypotenuse on triangle A, which remember was 5. And so if I say that the smaller hypotenuse is called lowercase h, we can go ahead and state that the scale factor SF is equal to capital H over h, which is equal to 5 root 5 over 5. And I'm sure you can see this right away, but the 5's cancel each other out, leaving us with a scale factor which is equal to the square root of 5. And consequently, to answer the question, since we were asked for the value of a, which is the number underneath the square root, we can go ahead and state that a must equal to 5. And so I'll write that here, and I'll box my final answer. A equals to 5. And we're done. That's how we can answer this 10-point IGCSE past paper 4 question on transformations.